Right, there are a couple of things we shall be focusing on today, but I decided that we start by looking at a couple of the methods that appear at the beginning of this exam. Right, so now Euler's method is one of those, and the modified Euler as well. So I thought it would be ideal for me to just have a word on Euler's method and also the applications of Euler's method in exams. So obviously we shall have this discussion, and during your own leisure, you will take note of the things, etc., etc. But yeah, from time to time, you might use your computational skills. For example, okay, we start by giving the statement of the method. One way to state Euler's method in standard literature is to say Euler's method is, right, what is Euler's method? It is W naught equals alpha. And what is this? This is the initial value. So these are initial value problems we're dealing with. So we understand, and we need to understand that Euler's method is for solving what we call the initial value problems, IVPs. Okay, so becomes the initial value, and therefore this one here becomes the relation we use to solve the problem at hand, because we're given a problem and we must be able to solve the problem. But let's look at this example, because what happens in the assessments in the exam is that you are just given a problem and you're asked to solve the problem. Normally the problem is in terms of y and x or y and t. Okay, I chose y and t here, but it can be any variable. Okay, use Euler's method to approximate the solution to y primed. Okay, equals y minus t squared plus 1. Right, and you have that your t lies between 0 and 2 inclusive, but y at 0 is 0.5 at t equals 2. Use h equals 0.5. So this is what we have, and we need to solve this problem. Right, so what are we supposed to do here? We look at the solution to this example, because they're saying use Euler's method to approximate the solution to this. So we want to find the approximate solution to this differential equation, right, where t lies between 0 and 2, but at t equals 2. So we want to find, estimate this at t equals 2. So we want to find y at 2. So yeah, so the question here is, here's a solution to that, to this problem. Right, so the solution to this problem is to say y at 2 equals what? Or is approximately what? And that is the essence of this question, because we are interested in actually getting an approximate value. So we are really saying y at 2 is approximately what? Why are we saying that? Because it is at t equals 2 that we must approximate the solution to this particular function. All right, and obviously we use the step because we shall take a couple of steps in the estimation process. And there are a couple of problems, obviously, I'm going to give to you for practice purposes. We shall try a couple of problems to make sure that as our strategy to learn this now, a bit more practice exercises are necessary. Okay, and I shall bring a lot. Okay. So that is the question. So how do we start? So for this problem, right? So we note that for this problem, we have that y primed is equal to y minus t squared plus 1. Okay, that is what you're given. And obviously you have the t interval, and you also have the y at 0, which equals 0.5. So you have those kinds of things here. Okay. Right, so we know that for this problem, we introduce a new function, because there are two variables that occur on the right side of the equation after the y primed, they are both t and y. So you actually order them in the following manner. So you say t and y, or like x and y, because that is how we write ordered pairs. And this is y minus t squared plus 1, like this. Okay. Right, for this problem, we have that y primed is that, and which means that from y primed is written as a multivariable function. In this case, sort of a bivariate function with a function in two variables, t and y, like so. Okay. With that said, we can then say so. Right, to use Euler's method, given this, we need to just estimate this, and after we need to estimate it at t equals 2, so we shall find y at 2. Now, we start with the initial value. Now, the initial value is y at 0. What is y at 0? Y at 0 is 0.5. It was just given in the question. That is the initial value. So we start and we say it's 0.5. We need to remember what I said, because according to Euler's method, there are two things that we use in Euler's method, and I'm going to state them here. So if we look at Euler's method, we've just stated that, but I'm just mentioning that here in passing. Right, Euler's method means that we say the initial value, and then we then say how we find the successive values of the estimation, and we put wi plus 1, wi plus h. Then we have f as a multivariable function, in this case of t sub I wi, like so. And this is true, obviously, like we said, for each of the i's. Like if you look at the I, which is 0, 1 until n minus 1. So yeah, you have that. Now, what is all this here? Now we're going to use this one to find the rest of the successive values. So in other words, the initial value is this one. What is W1? Right, so in other words, W1, we shall find it by, to get W1 means I is 0 here. And if I is 0, then we shall have W0 plus, yeah, we can write H, doesn't matter. And then we have FT, right, because I is 0, so it's T0. T sub 0, W0, like so. Okay, what is this? What is W0? Okay, we saw that W0 is alpha, and alpha is 0.5 here. So which means that we shall have, what? We shall have 0.5. What is the H? The H here is 0.5. We just stated that one in the beginning of the question. Yeah, each question has its own H, and it's given in the question always. Right. So now you have this. Yeah, so you just have this. Now you can write it. Okay. A couple of ways to do this. One way to do this is to write out the function. I think that is what I'm going to do. Can I just make it easier and just write the function, and then I'm going to just use one function to estimate the rest, okay? Because we shall just find a bit more values, and I'm going to draw a table. We're going to construct a table of the Euler's method just to understand this method better, and then we shall look at the modified Euler as well. Okay, I was effectively then saying, now in view of this here, we can then say, if you look at wi plus 1, this is wi plus h, okay? Now the f, the FTI, WI, FTI, WI, it's going to be this. So it's going to be, because the WI, it's going to be like in the place of the Y, so it's going to be this. And then the TI is going to be TI squared, like so, plus 1. Okay, so this is just the relation we're going to be using. This basically becomes our Euler's method in this particular question, because they only differ by the differential equation that is given. So at this point, for example, we shall say W1 equals W0, because we want to find out that's this W0, then we want to find W1 by making I 0. So yeah, we have that. So yeah, let's just write this. So this will be 0 minus T0 squared plus 1, which means that you have W0, which is 0.5 plus H. Okay, now H is 0.5 for this question, and then W0 is the initial value, 0.5 in the question, right? Minus the square of T0. What is T0? Okay, so obviously we understand that the T0 goes is the value of T at W0. And we understand that that one is 0 as well. Right, so it's exactly 0, so you can write 0.0, just two decimals. Like this one is 2 decimals, so the W0 goes into T0, and then we have the 1, like so. And then now you have this, and with this said, you can simplify this and write 0.5, okay, which is this one, plus the 0.5. And then we have this one here, which is, this is 0. So having 0, in other words, you can put some parentheses here like so. Right, so you have 1 plus 0.5, which is 1.5. Like so. And then if you continue, then this is 1.25, like this. All right, so this is what we get. So the next thing is we have W2. Right, so W2 is obtained from the same relation. This one, so W2 is when it's obtained when I is 1 here, because 1 plus 1 which is 2, which means it's W1 plus H. Right, which means it is actually W1 plus H. Right, and then we just need to remember the formula, which is W1 minus T1 squared plus 1. Right, which is W1 minus T1 squared plus 1, like so. Okay, now it just remains for us to recall what we got. Like, because these are successive approximations, so we know W1 is 1.25. So you shall, in the place of W1 here, you put 1.25 plus the H, which is 0.5. And then we have W1, which is 1.25. Okay, we got it in the previous estimation step. And then we have the T1. What is the T1? Right, so now the T1, because we started at 0, and then we're moving in the steps of H. So we're gonna draw a table. But if we start at T0, which is 0, and then we add H, is 0.5. So which means that T1 is gonna be 0.5. Right, so T1 is 0.5, and then you square this one, and then we add 1 like so. Okay, this is what we are able to get. And so now let's just simplify W2. 1.25 plus 0.5. And then if you do everything here, it's 2.0. 2.0 and then 2.25. Okay. So obviously this is what we get for W2. And then we continue, and then we shall just do W3. And then you shall understand why W3 is necessary. You shall understand at what point are we really going to stop. So let's look at W3. What is W3? Okay, obviously we remember that what the formula that we're using. Right, we remember that Wi plus 1 is actually always is Wi plus H into the derivative or the differential equation that we put here. So, but in this case, it's actually the same as Wi here minus Ti. You square this one plus 1, like this. All right, so with that said, then, I mean, what we're then getting is that, okay, then this is W3. So what then it means is here we put I equals 2, which means you have, okay, W3 becomes W2 plus, you can put H, okay, just um, uh, obtaining W3 here, just maintaining the rest of the symbols, and then the next step we do substitution. Right, so W3, when I is 2, then it's going to be W2 plus H, and then this one is W2 minus T2 squared plus 1. And then obviously we have W3 is W2. We've already got W2, which is 2.25. Right, 2.25 plus H, it's 0.5. W2 is actually 2.25 minus the T2. What is T2? Right, we have already seen that T0 is 0 for the initial value. And then T1 when we add 0.5, because our H is 0.5. So if you add 0.5, then it's 0.5 here. Our T2, if you add 0.5, then it is exactly 1. Okay. So in other words, you can just, for consistency, we can just write to 1 decimal place. And then obviously now we can do T3. If you add 0.5, then it becomes like 1.5. Okay. And then T4 becomes 2. If you add 0.5, then it becomes 2.0, which is 2. Okay, so, right, but we're interested in T2 here, which is exactly 1.0. Just 1, but yeah, just to maintain the same number of decimal digits plus 1. So which means that W3, okay, so if you have the 2.20 and then 0.5, okay, and this is what you get. So this is exactly 2.25 plus 0.5. And then work what is inside the parenthesis, this here. Okay, this is like 1 minus 1, minus 1 plus 1, which is 0. So we have just 2.25 here, like so. What is W3? Right, so W3 becomes 3.375. Okay, so this one is our W3. Right, after we got W3, so then at the point we had W3, we used T2. And then now we continue with the process. How would we get, for example, how would we get W4? And right, so Wi plus 1 formula is Wi plus H. Then we have the formula here, which is Wi, and then you square the Ti squared plus 1. Okay, just writing that. But now if you find W4, right, it occurs when I is 3. So this one is W3 plus H, and then this one is W3 minus T3 squared plus 1. So now let's analyze this carefully and see what this is actually going to give us. Because now we understand something, that we are going to get W3, okay? Let's just write this out. So now if we get W4 right now, so we note a couple of things, that W4, for example, is the same as what? W3. What is W3? W3 is 3.375, okay? So W3 is 3.375 plus H. 0.5. And then what is W3? Is 3.375 minus T3. What is T3? Right, so we check. T3 is 1.5. Yeah, 1.5. So we substitute T3, which is actually 1.5. But we square everything according to the differential equation, then we add a 1, like so. Okay, so which means that W4 can be seen as 3.375 plus 0.5 into 2.125, like so. And then what is this? Well, it means that W4 is the same as the following. Right, it symbolizes that W4 is the same as, if you add everything, it is 4.4375. Okay, so we got W4 right now. And then, right, so what is the meaning of these in terms of what we have got? Because the couple of things that we are able to analyze, because now if we get, for instance, W0, let me just write here. I want to mention something about W0. We saw that W0 was given by the alpha, but W0 is Y0. Is Y0, which is 0.5. Okay, let's just write those to explore. So W0 is Y0. It is alpha in our notation, using our notation. And then now if you get W1, W1 occurs with just one step more, adding H to 0 to the initial value, so we get 0.5. Then we have W2, we add H again, okay, which is exactly 1.0. Okay, just maintaining the decimal places there, decimal digits. Then now if you have W3, you add again the H to the 1.0, getting 1.5. So which means that W4 is actually 2.0, meaning this one is actually Y at 2, okay? It is Y at 2, and then this one is Y at 2, and then this one is approximately Y at 2, which is what we had to estimate. And obviously, I mean, the conclusion then hence is that hence we have achieved using Euler's method that W2 is approximately 4.4375. Okay, so this is what we're asked to estimate by using Euler's method, and we have managed to estimate. Okay, right, and now I want to give a comment. There's something we call the difference equation. Right, so we shall speak about the difference. The difference equation, just some terminology in relation to Euler's method. What is the difference equation? We note that the equation, for example, right, the equation Wi plus 1, which equals W sub I plus H F T sub I W sub I for each I equals 0, 1 until n minus 1. Okay, the equation, this one for each of these is called the difference equation. So this is called the difference equation. Okay, call the difference equation associated. Okay, so it is most certainly associated with Euler's method. So if we remember, therefore, Euler's method, then we just need to remember the difference equation and to just take into account the the initial value, or obviously. Okay, so that is the difference equation there. Okay, right. Now, I want us to explore this method a little bit further and analyze this in detail in relation to how it is asked in the exam, because obviously this is by and large how it's asked in the exam. But it is also very important to be in a position to use this result to solve problems in tabular form. In tabular form. So how do we state and write the results in tabular form? Okay, so we're gonna look into that just now. Okay. Now, for example, I would say for the example above, for the example 1, because that's what it is. Right, because now we got the example 1. It's a remark I want to give there. If capital N is 10, so we go up to capital N equals 10. But if we go up to capital N equals 10, it means we're going to stop at 10 minus 1, which is 9. But we shall be having like 10 I values, and therefore 10 W's. Right. Right. For the example above, if N equals 10, we shall, and we're going to do this now, we shall determine, right? So we shall determine approximations. Approximations and compare this with the exact. Okay, so the exact values, now we found the approximations, but you can compare with and compare these with the exact values, right? Given by, right? So now we give the formula that is exact, the solution to the differential equation that we were dealing with, right? So if we solve that differential equation, normally in this course, the method, you are not asked to solve the differential equations. You are just asked to estimate, right? So, but now the solution is this one. So we can compare the values we got with the exact ones. And I want us to just compare, right? So, and we shall use a table to illustrate the results, okay? Right. So now there is a table. And this table here is going to have the TI values. And then it's also going to have the W's. Okay. And then it is also going to have the YI's, which are the same as Y sub I is the same as Y of Ti. And then, because we are comparing, it makes sense to obtain the difference if the exact one here and the approximate one, the approximate values, are they the same or not? So to do that, we obtain the difference. We want to see if Euler's method is accurate or not. I mean, if we are to compare the values we get by using Euler's method versus the exact ones. Okay. For example, we shall start, because this function was started at 0, 0. Then we just add 0 0.5. Right. We just add a couple of the 0 0.5 values, etc., etc. Right. Okay. 0 0.8. What is W? Okay. Just want to refer to what we got here. Right. For example, we got the W's. Right, we got a couple of the W's here, and each one of these W's obtained at a given, like W3. W3 was actually obtained. We saw that W4 was obtained at 2.0. So W3 was obtained at 1.5. So this one was obtained at 1.5, for example. And so we're going to just write those values down. And I want us to note and see exactly what the difference is here. Okay. For convenience, all right, so we're going to do this. Right, for convenience, there is a desire here in this question to take. So yeah, I'm gonna say W. So we're gonna use a different H for just for to get a bit more values. But yeah, right, like because we want to stop at 2, but we choose, this is just by choice, please. It's always stated in the question. So choose H to be this, and we take the, what you call the difference equation, which is always Wi plus H. And then we put what we got. And then this one is going to be Wi minus, okay? And then this one is Ti squared plus 1, like so. So obviously, with this said, we then are going to, if we use this one, it's going to be 0.2 here. It's going to be 0.4, 6, 0.8, 1.0, 1.2, right? And then 1.4, 1.6, 1.8, 2.0. And then we already know, like at the beginning, W0, we got that to be obviously W0 was 0.5 in this question, because at 0, right, W0 was alpha, the initial value, so W0 was 0.5. So obviously that's what we had before. So we have 0.5, and you can just get a bit more decimal points, like so. Right, not very, this is very optional, the decimal digits, unless stated in the question. Right, so now, but we can get 0.2, right? Let's just practice, and then we're going to extrapolate the rest. So we're going to say, for example, we want to get W1, which means I is 0. We got W1, but for a different H. So this is going to be 0 plus, when H is 0.2, it's no longer 0.5. And then we have W0 minus T0 plus 1, which means W1 is, yeah, W0. We saw it's 0.5. So it's 0.5, and then the H is 0.2, and then the W0 is 0.5, and the T0. Right, obviously we can see that for W1 we have T0, but T0 is the beginning one, which is 0. Okay, 0 squared plus 1. Okay, T0 is the beginning one. And then now we just add everything here, and we're gonna, okay, we can just 0.5, and then we have 0.2, and then we add everything here. It's 1.5. We use a calculator to get W1, and then it's going to become 0.8. Hey, if you use a calculator, you can just check that is 0.8. But that would mean that this one is 0.8. 1, 2, 3. All right. We do like we did before, but I want to illustrate the idea. So, which means that for this particular question, I'm just going to extrapolate and say if we continue like we did before to get W2, it's going to become 1.52, 1.152. Right, so it should become 1.152, and then how many decimal places? 2, 4. And then you put a 0 there. Okay. And then let's continue. Right, so we're going to find all the estimates, and then we shall find the accurate here. Okay, the estimates like we did before, so I'm going to just extrapolate to make sure that we're straight to the point, and we go to other equations, and we just want to get the idea here. So this is 5, and this one is 0.4. And then at 0.8 is 1.98848. And then this one here at 1.0 is going to be 2.45. 81. 760. You've used a calculator. And then at 1.2, it's going to be 2.94. Okay, we're going to have sessions where we do calculator practice together in our next meeting, 112, to create that efficiency when it comes to calculator usage, because it's very important for each of the methods that one just able to use their calculator to do the calculations, because that is what must be learned, calculator usage. So 1.6, for instance, becomes 3.9501281. Okay, there's going to be a lot of calculator practice tomorrow. So you have 4.428 1538. And then the last one is 4.8. So this one of yours at 2.0, it's not the same as the one we got before, because we're using a different H now. Yeah, so, but it is 8.6, and then we have 5.7, and then 8.45. Okay, now we need to remember something. But what we remember is the exact one. What is the exact solution to the differential equation? So we saw that y at t, right, I just try to write that a little bit clearly here. So we remember that y at t is equal to what? Is equal to t plus 1 squared minus 0.5 e to the t. Okay, so this is the exact one, but now we need to substitute here and just, okay, let's practice. Okay, if we put t equals 0, like t0 here, because it's yi, so this is going to be y0 for the beginning, and then it's going to be T0, having the argument T0. So if we put T0 here, what is T0? T0 is 0. So it's going to be 1 squared minus 0.5 e to the 0. So it's 1 minus 0.5. And 1 minus 0.5 is exactly 0.5. Right. Okay, there's some decimal places, but you need to be consistent, so we have the same number of the decimals. Okay, so now let's look at the next one. So if you have like T1, which is 0.2, so you put 0.2, it's going to be 0.2 plus 1 squared. Okay, let me just write some of the things. So you're going to be like 0.2, and then it's going to be 0.2 plus 1, and then it's going to be 0.5, and then e to the 0.2. Okay, so obviously, if you look at this particular one, you're going to use a calculator for this. But if you use a calculator, what you're getting is 0.8292, 0.8292, yeah, 0.8292986. So, okay. Yeah, you can just check that we use the calculator. This is 0.5. So yeah, you're going to have that 0.8292, 986. And then now you're going to do the third one at 0.4. But if you do y at 0.4, you realize that it is 1.21408 Let's say this calculator practice I'm going to do from tomorrow. Okay. So I'm going to just make sure that you have the calculator and we can discuss and you can share your own findings on your calculator. So it's 1.2140877. So that is at 0.4. And then there's 0.6. 1.6489,406. You have 2 point. Here you have 2.12. 72295. And then here we have 2.6408591. Okay. Let's see. At 1.2, 3.1799,415. Okay, this one is because I've done it, but yeah, with the others, we shall use a calculator even today. We shall try to be faster. Right, like 3.73, then 24, like 1, 2, 3 zeros. And then now this one is going to be 4.2834,838. And then now you have 4.8151,763. And then here you have 5.3054,720. Okay. Now, okay, we can just get like, if you want to get at t at 2.0, and then you just put 2.0 here. Okay, 2.0 is like 2. Okay, so this one is easy. Right, so for example, if you use a calculator and you put 2 plus 1, It's gonna be like 3 squared, and 3 squared is it's a 9. And then if you have a 9, then you're gonna have yeah, which is a 3 squared. So a 3 squared is a 9. Okay, so yeah, you can even use my calculator. All right, so yeah, that is 3 squared. Can bring my calculator here. Just one sec. Just to show, but yeah, it's I know it's already there. Okay. Um. Right. Let me just bring the calculator. Just one sec. Just for practicing. Right. So let's just practice. For example, where's the calculator? Is this one? Right. So for example, we're just practicing. Right. Okay. So we're doing a, like a 2.0. So the 2.0, you can substitute here, which is going to be 2 plus 1, which is exactly, you can even do it that way. So you can do like 2 plus 1, and then you close, and then you square, and then minus 0.5 times. Okay. So obviously you do the E part, and the exponential part is already there, so you can use any of these. Right, so let me just see which one would be the best E symbol. You can use any of them. You can use this one. You can also use, but normally there is a standard exponential. This is standard exponential. Yeah, this one. Okay, Shift E, and then you put the 2, like so, and then you close. Okay, and then now you give that. Okay, so obviously the real value you can see is 5.3054719, like 720. Okay, so something like that. So in other words, it's sort of uh, the the estimate you're getting, or rather these are sort of the accurate values. But with that said, then we can get the actual difference just to see how Euler's method performs in relation to what is accurate, because this is what Euler suggested. But that, okay, you can estimate, this estimate is not going to be far. For example, 0.5, 0.5 is the same. Here it's 0.8, then it's 0.82. You can see that the real one is a bit higher, etc., etc. So we're interested in just finding the difference. Okay, let's just find the difference. So to find the difference, then we're going to proceed as follows. Okay, I'm not going to waste much of your time there. Right, to find the difference, I've already done the difference. So now the difference, for example, between these two, if you find the difference and then get the modulus, 0.5 minus 0.5, which is 0. Right? So like this. Then here you subtract the modulus, means you can subtract them in any order. So you can say yi minus wi, or the other way around. But now what you're getting is 0 point. So all this will be positive because of the modulus. And then you have just a comparison you're doing, 2986. And then the next one, the third one, 0 0.0620, 877, 0 0.0985, 406, 0 0.13, 87, 495, 0 0.182, 68, 31, 0 0.230, 13, 03, yeah, like so. And then we have Yeah. I might just be missing things around. Let me just check 0.00 and then 29 here, and then 0.062, and then 0.98, and then 0.13, 0.182, 0.2, um, 0.280, 62, 66, 0.333. How many? 2, 4. Okay, there are 4 threes and then there's a 5, 7. Okay, yeah, they are in the same order, but yeah, it's just that this is just, I'm just trying to congest everything here. So 0.38, 70, 225, and then you have 0.43, 96, 874. Right, so yeah, this one matches with this. They're in that order. Right, they are just exactly in that order, like so. Right. Um, is it okay? Now, this is the comparison just to show that indeed Euler is not accurate. Okay, it's not, does not give the exact value as what you would get if you solve the actual differential equation and then find the accurate value of the function at a given value of t. Okay, right. Now we've just seen the estimates there, and obviously it's part of what we need to learn. Right, and then the couple of exercises, obviously, that we need to do. Um, and so let's just practice here, and use some and do some exercises. Right, because the exam is about exercises, so let's look at these exercises. Right, just a sec. Need to clean up. Right, so now the exercises are, what are the exercises? For example, here is one exercise. It has lots of questions. And it says use, like in the exam, use Euler's method to approximate the solution. Right, so now if we want to approximate the solution, yeah, to approximate the solutions, okay, there are going to be several solutions for each of the following initial value problems. Okay, we're just gonna see, and then we can just practice with this method, and then we shall look at another method that, and then obviously we shall also look at the modified Euler as well, because if they don't ask the Euler, then they ask the students to use the modified Euler. Right. So if you have y primed is t e to the 3t minus twice y, when the t lies between like 0 and 1. Y at 0 is 0 with h equals 0.5. Y primed t minus y squared t 3 at 2, y at 2 is 1, which is the initial value. But what is h for this second question? H is also 0.5. C, y primed is 1 plus y out of t. T, y at 1 is 2. With h equals 0.25. D, we have y primed is cosine twice t plus the sine of 3t. Okay, so just to clean this up. Right, so we have now this one is a sine of 3t. Okay, this. Right, let me just clean this up. Apologies for the drag. Right, apologies for the drag. So, right. So now let's just, now I was saying sine 3t here. And then we have 0, 1. Y at 0 is 1. With the h is 0.25. Okay, yes, some exercises this from the material for the course. Okay, now I've taken this from the material from the textbook, from the prescribed textbook for this course. Now, with this said, okay, this can be solved. They're all the same. You can just choose any random question and explore. For example, right, you need to use Euler's method to approximate the solutions to this. What are the solutions to this? Okay, first, I'm going to mention something. With the problem we did before, our t was between 0 and 2, and so we found y at 2 approximately. Y at 2. So we're going to find approximately y at the end points. At the end point, at the greatest end point, like you shall find at 1. Okay, so like this one is easy because it does not take a lot of steps, you know. With 0.5, then you can say 0.5 plus 0.5, then you're at 1. So let's just practice to demonstrate the idea. Solution, quickly. Right. They said they're going to be a lot of calculator usage tomorrow. Y primed is, in that question, is exactly t e to the, I can use t or x, okay? Sometimes it's popular to use any of these, okay? The exam uses, it's y here. The exam uses any of the, they use either t or x, doesn't matter. So you have 2y here, okay? I just want to illustrate Euler's method with this particular exercise from the textbook. Right, so you have 0 with h equals 0.5. All right. Now what do we do? We need to just remember Euler. What does Euler say? Okay. Euler says W0 is alpha 0. And then it says the difference equation. This is Wi plus 1 is Wi and then h. And then you have f of ti Wi. Okay, this is exactly what we said is the difference equation for Euler's method. Now, with that said, then what do? We solve. Okay, this is enough. This is the difference equation. All right, with this difference equation, then we are quickly able to solve. How do we solve this? We're able to solve this by using the steps we used before. For example, what is W0? We saw that W0 is the same as Y0. And Y0 is what? Is 0 in this question. Okay, if you can tabulate these values, you can put them actually in a table. And then now the next thing is we're going to do W1. Okay, but first, I suggested that we just write the general difference equation for this particular differential equation. Like we're going to say Wi plus 1 is Wi plus H. Then in this question, we note that f of Ti Wi, what is f of Ti Wi in this particular question? It is exactly this, okay? So it means that it is Ti e to the 3Ti minus 2 the y. What is the y? Is Wi, okay? So this is exactly what we are able to get, okay? So with that said, then we just substitute here this we put here. So it becomes Ti e to the 3Ti minus 2 Wi, and then you close like this. Okay, now with that said, then what do we do here? Right, so we're gonna actually be able to do some of the things. What are some of the things? Okay, like let's do W1, because we already have W0. Right, W1 occurs when I is 0 because 0 plus 1 is exactly 1. So this one is W0 plus H. Then you have T0 e to the 3T0 minus 2 W0. Which means W0 is, okay, so this is 0 plus, what is H here? Okay, 0.5. So it's 0.5 into T0. We saw that T0 is 0. Right, it's 0 e to the 3, 0. Okay, just to try to write it clearly here. So it's going to be exactly 0 e to the 3, 0 minus twice. What is W0? It's 0 in this question. Like this. So, okay, with that said, we continue. Hello, Mark. Siyaphila njani, Mark? Okay, yeah, I'm just talking to someone now. Okay, yes, Mark. Ewa, Mark. Uh-huh. All right, that's fine. I'll see. Yeah, I'll see my routines after my class, man. Yeah, and then yeah, we'll spend discussion then. Okay. Okay, yeah, that's fine. That's fine. Yeah, we see class in at the moment. What yeah, never, man. Yeah. Yeah. Yeah, South Sinzana, man. Okay. Okay, thanks, man. Okay, Siabo. Okay, thanks. Goodbye. Mm-hmm. All right, my apologies. I had to speak to my mom here. Okay. All right. Now, okay, we have W1, which is this. Okay, so now everything here is therefore going to be 0, 0. So this is going to be 0. Right. Okay, we agree that this is the case. So is certainly going to be 0, 0, everything. So for W1, and then now, obviously, now we need to estimate the value of this. But now, there are a couple of things you need to note that W0 is the same as Y0. And then W1 is the same as the next one at T. So you're going to add 0.5, and then you get 0.5, which corresponds to T1. And then obviously now, for example, if you have W2, is going to be at the next one, which is going to be 1.0. 1.0. Okay. So, okay. Yeah, that's what we have. Okay, now we need to just take one more step because we have t between 0 and 1. So we need one more step. Okay. Right. So if you have this, then you have W2. Right. So, yeah, W2. What is W2? Okay, we can get it from here. Right. W2 is going to be, for instance, W1 here. Okay. W2 is going to be W1 plus H. Okay, plus H. Then you have Ti. It's just going to be T1. Yeah. It's going to be T1, then e to the 3T1. Right. So it's going to be T1 e to the 3T1. And then, right. Then you have minus 2W1. Okay, minus 2W1. Okay, so with that said, then we have W2. Okay, what is W1? Okay, we got W1 to be 0 in this question. It is clearly 0. Okay, so right, so we're gonna have W1 is 0, that we know. H for this question is 0.5. T1 is 0.5. So T1 is 0.5, e to the 3, 0.5. Minus 2. The W1 is exactly 0. Okay, so it's 0. Right, let's get this here. So if you have 0.5 times 0.5, so this one is squared. E to the 3 times, which is 0. Okay. Okay, let's just leave it like that. Okay, leave it at the top is 3 times 0 point that and do this on a calculator. And right, so it's going to be 3 times 0 0.5. Okay, this is 0. Okay. Right. Okay. All right. So yeah, I'm just doing this quickly because this one I had not done. All right. So now if you have this, okay, 0 0.5. 0 0.5. Okay, so it's 0 0.5 squared times E. Okay, we can use the calculator. Okay. Can use the calculator that's there. Okay. Um, right. Can use this one just to make things easier and more clearer. Okay. For example, if you use this one, 0 0.5. Okay, so you can put parentheses here like 0 0.5 and then you close. And then you square everything. All right, there's a square. Okay, and then now you can multiply that by the exponential, which is shift above the natural log. And then you have 3 times 0 0.5. Okay, so we have that one, and then you close like that. Okay, so yeah, you have this. Okay, so which is 1.20, right? Which is 1 point. Yeah, I know it's gonna actually go off when I attempt to write, that's fine. All right. Okay, just to bring the calculator back, just one sec. Right, so this is the calculator value, and then I'm just going to write it down. It's not a lot that I'm going to write down here. Okay. Okay. All right. Okay, yeah, we already got it. I'm just going to put the value. So it is 1.120 for 12368. So we are 1.1204, 222, three of them. Then six. Okay, yeah. Right, so we got W2. So yeah. W2 is approximately 1.1204222, then 68. Now, okay, we have seen, so now I want us to just go back. So W2 is what estimates 1.0. So, okay, which means 1.0. Okay, so which means it is 1.0. Okay, 1.0. Okay, it estimates W2. And then, well, normally you can use an equal sign here. Yeah, so W2 can be equated to this. But yeah, it's in this case, it's quite more approximate. The most appropriate is the approximate sign, which is 4222268. Okay, but now watch that we get these here. Okay. All right, so we get the answer like this. Okay, so right, but now this is the answer to the question. And then now I'm gonna extend this because there's a solution to that, so we can just find the correct one. For example, you can just compare, but for example, the actual solutions to the problems in exercise 1 are the following. Okay, the four of them. Um, okay, let's write this. All right. So, which means the solution. Okay, wait. The solution to this differential equation, y primed equals, so the solution to y primed minus twice y is, okay, yeah. The solution to that, you don't, it's given. Normally they give it in the exam. So it is y t 1/5. T e to the 3t minus 1/25 e to the 3t plus 1/25 e to the minus 2t Okay. Okay, so now we have this. Uh, 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 okay, yeah, this is what this sort of becomes the solution to that equation. All right. Now if this is a solution to the equation, then what is y at 0? So that okay, let's look at y at 1.0. Find that one, 1.0, which is 1 to 5, 1 e to the 3 minus 1 out of 25 to the 3 times 1 out of 25, 1. Okay, so just need to um, get the answer to this. Okay, right. To get this one, just see 1 minute. Okay, let's skip this. Okay, right. Okay. Doesn't matter. 1 divided by 5, a bit like this. And then you have E shift 3. Then now you have the minus. Just practicing with this one. Okay. Then you have 1 out of 25. Okay. There's a bit more calculator usage because this maybe takes a bit of time. Okay. Right. Calculator practice is necessary. Right. Then you have 3 here. To beat time in the exam. Plus 1 out of 25. E and the minus 2, like so. Okay, so yeah. Right, so it appears that we're getting this value, so I need to write it down. So I'm just going to take note of this value because I'm just going to write it down there, and we're going to sort of compare with, this is interesting. This is interesting because it's vastly different anyway. It's vastly different. Okay, right. Just note. When I analyze this and see, but it's so different. So 21909 319. Okay, so 3.219 099 319. Okay, so yeah, that is sort of what you're getting. Is the exact one. And then obviously we have the you have that kind of difference in this case. Right, we have the difference is so big. Okay, but yeah, I'm just illustrating the idea. But now, obviously, what we have is therefore like the Euler 1.0 is approximately this, and therefore the exact one is this. Okay, is the 3.219. You can see that there's a very huge difference. Big, big difference. But yeah, note that. Okay. So, but yeah, that's what we're getting. And then, okay, so the next one and so on. And then the other exercises I'm going to just give now as well, so that you practice. All right. These things are the same, all of them in the textbook. Okay, let me just give other exercises. Okay, the exercises I've given here, I know the others that I've given, but we've not solved. So I'm going to call these exercises 2. Okay, yeah. This ones will involve some rational functions. Okay, they involve some rational functions and then use Euler. Okay, we're going to do the others as well. I'm going to highlight them in my next meeting. The ones that I'm just going to give here and not solve here. We're going to do them in my next appearance. All right, we'll just highlight exactly what the answers are. All right, so use Euler. Use Euler's method to approximate. Okay, just 1 second. I'm trying to make sure that I'm taking the correct problems here, because these are coming from the prescribed book. Okay, use Euler's method to approximate the solutions. Yes, to approximate the solutions. Right, the solutions okay, the solutions for each of the following. For each of the following initial value problems. Right, so if you look at part A, which is 2 minus 2ty. Okay, just try to write this a bit more horizontally. It's too tilted. Okay. For example, if you have this, okay, I'm gonna just gonna do one of these or two of these, and then move on to the next section. Right. So 2ty. These are just rational. But there's nothing different. Okay, the prescribed book just does not change this. They just give just different functions, but it's still Euler. Right, so you have y0 is 1, a bit more steps, because you have h is 0.1. Okay, so obviously because h is 0.1, now the t is going to be up to 1, so 0.1, 0.2, 0.3, and so on. Okay, just note that. Right, so right, you have y squared, 1 plus t, 1. y at 1. Then 2. Okay, see? All right. These exercises, the ones that we're gonna not do today, I'm gonna highlight the answers in our next meeting. Right. So this is t to the minus 1. Then you have like y squared plus y. Okay, they're not very different anyway in the book. So I'm just sampling or randomly picking from the textbook. But right, so you have y at 1 equals minus 2 with age 0.2. All right, so yeah, let's have D. Um, so T y to the minus 1, 0 T1, y 0 is 1 with h 0.1. Okay, right, so we have that. Okay, so now, okay, this is just use Euler's method to approximate the solutions for each of the following initial value problems. Okay, I know I've given others. They will be there actually as part of the recording, but there are others that are here. And so we can just do these. Okay, we did the others like with initial value y0, it was 0, but now there's y0 is 1. Okay, so this one is we're just gonna illustrate the idea. We can also use this one. What is the difference now? This one has the initial value that is like not like an integer, in which case, therefore, it'll be very interesting to see how the solution of this one is going to behave. But yeah, it's not a nice problem because it has ln2, which is already decimal. Okay, but we can just explore, see which one we can, any one we can do. Now, this one, for instance, okay, but now I want us to focus on this. The values of t are perhaps the difference here, because here you're starting at 1, 1. You're starting at 1, 1. You're starting at 0, 0. Okay, so you're starting at 1, and then you're adding this until you get to 3. Okay, we're going to do any of this. Let's just do C, for example. Solution. All right. So, yeah. Okay, I chose C, but the others does not mean are not to be done. Okay, C is y primed. Um, T to the power minus 1, y squared plus y, and then 1, t lies between 1 and 3. Y at 1 is the minus 2. With h equals 0.2. Okay, now let's look at the uh, solutions to these and see what we can do. First things first, we're going to remember Euler. Right, so we know that W0 is alpha, Wi plus 1 is Wi plus H, FTI, Wi. Okay, right, so now, okay, let's look at like the original thing, the initial value. Okay, so W0 is the initial value, which is wide 1 and it's minus 2. Okay, we need to get the rest of the values, like according to until we get to 3. But let's start with first the formula. Okay, we called this the difference equation. The difference equation associated with Euler. Difference equation associated. There are many difference equations, but this one is associated with Euler's method. Okay, Euler's method. So let's look at W1. Okay, first Wi plus 1, which is Wi like this, H. Okay, let's look at F. What is FTI here? So this one is going to be Ti to the minus 1 squared plus Wi squared. Okay, so we have this. Let's see. Okay, yeah, you can remove this bracket. This one. Right. Okay, put a dot here. Right, so we have H times the F. Because in this question, we know that F of T, you can call it Ty, is T to the minus 1, Y squared plus this. Okay, so yeah, we have that. Which means, okay, yeah, we can get the rest. Now you can get to W1, which means here it's 0 because I is 0 to get W1. And then you have H here, and then I is 0, just T0, and then W0. Okay, right. So, and then now you have W0, which is minus 2. Okay, let's look at H. All right, 0.2. What is T0? T0 is 1. So anyway, 1 to the power minus 1, just 1, just writing that. And then now you have W0 minus 2. What is W0 minus 2? Like this. Okay, so now you have plus 0.2. Okay, so we have 4 minus 2, 2. And then this is 0.4. So it minus 1.6. Let's check this. Okay, you need to check this, but yeah, I believe it is. Okay. So now you'd have this, and therefore this is sort of the answer. But yeah, we have a bit more iterations to compute, or a couple of the approximation steps. So if you have this one, okay, so you have that. Yeah, okay. Right, but yeah, this means W1 is minus 1.6. All right. Okay, if W1 is minus 1.6, okay, we must compute so many. And then I must do W2 according to this formula. So just going to write the formula here. Okay, Wi plus 1, Wi plus H, T to the minus 1, Wi plus Wi. Okay, all right, now, okay, let's just, all right, let's do W2. So it's going to be, okay, it's going to okay when I is 1 here. So it's 1 here. H is fixed. So yeah, this is Ti, even say. So just note that. Yeah, it's I here. Okay, because the T changes, but yeah, it's going to be T1, W1, 1. Okay, so what is W1? Okay, it's minus 1.6. What is H? 0.2 in this question. Okay, just pick this random one, 0.3. And then T1. Okay, we saw that T0 was 1. So this one you add 0.2. So it's 1.2. And then we have W1 minus 1.6. We square this one, and then W1 is minus 1.6. Okay, just practicing with this Euler. Okay, and then I'm going to do a couple of other methods after this. Right, the formulas can change a little bit. Sometimes you can find that it's not W that is being used. It's a different symbol, but the formula is the same anyway, just changing symbols. Right, so which is minus 1.6. Okay, so okay, yeah, need to do this. Just practice with this. Yeah, okay, but if one uses the calculator, then what you're getting is minus 1.6 and then plus 0.2. And then you have 1.6. You square that plus, okay, I'm just doing it on the calculator, please. I'm just going to write the answer because this one I did not do in advance. So yeah, you have this. And then now, okay. All right. If I do everything what the calculator is giving me, which I have to sort of believe is correct, is minus 1.44. Okay, right. If it's minus 1.44, that's W2. But there are a couple of notes we need to take. Like W0 is, okay, this drags. Right, so look, W0 is y of T0. Anyway, in this case is 1. And then now, if you have W1, which is T1, which is 1 plus 0.2, because H is 0.2, so it's 1.2. We took T1 to 1.2 here. Right, just one more. W2 is, okay, I know this is boring sometimes, but yeah, it's boring, but it's easy to forget and not be used to the steps. Okay, it's very important to just practice going through the steps. Right, so if you have like T2, then you have T2, it's gonna be like 1.4. Okay, so if you have this, okay, what am I trying to say with this? We can go through all these, but there are a lot, because you must go up to 3. T lies between 0 and 1 and 3. So T lies between 1 and 3. Okay, now if you do 3, excuse me, I wrote between 1 and 1 here. All right, so it's between 1 and 3. So in other words, you'd have what are you going to have here? It's W1, that's going to be this. Okay, so in other words, there's going to be a W that is going to be W at 3. But is going to be Y at T something. Okay. Right, so you need to just do that. So you can just do 1. You add 1.2. You add 1.2. You add 0.2. Get that? Okay. And then you add, it becomes 1.4. You add, it becomes 1.6. You add, it becomes 1.8. You add, it becomes 2 and 0. You add, it becomes 2.2. You add, it becomes 2.4, 2.6, 2.8, 3.2. Okay, now look. Now at this point, now this one is T0, T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, right? Okay, T0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it appears that this is going to occur at T10. I hope I'm not mistaken there by just counting the things and I did not jump anything or whatever. Right, so, but that is going to be exactly at that. And then we have W, W10. Okay, which is Y at T10, which is this, right? So Y at T10 is that. Okay. And then it's W10. But now, if we're going to use Euler, we can't find W10 without W9. So we must like go through all of them because for us to get W2, we used W1. All right. So it's okay. We understand that. But okay, let me just do one more to illustrate the idea. I know it's boring already. Okay. Right. So Wi plus 1. Okay, I'm going to change the method, please, to another method. Right, which is Wi plus H, and then HTI minus 1. Okay, and then Wi plus Wi. Okay, so all right. Okay, let's do W3. Okay, I wanted to do just one more because we did W2 here. Let's just do W3, but yeah. What is W3? When I is 2, does W2 plus H, excuse me. So this one is going to be T2, T2, W2, W2. Okay. Okay, now let's continue. W3 is W2. We got it to be minus 1.44. Minus 1.44 plus H, 0.2 in this question. Then T2 is 1.4. 1.4 from here. T3 is 1.6, so T2 is 1.4. 1.4 raised to the power. Okay, then you have W2 minus 1.44. Okay, we're gonna move to another method, please. Okay, this we're just practicing now. Plus minus 1.44. Right. Now, if this is the case, okay, so you need to use a calculator to do this. Okay, just bring up a calculator, please. Um, right, just bring up a calculator, please, and then we're gonna move to another method. Right. So, for example, we have minus 1.44, 0.2, 1.4, minus 1, and then open parentheses, then you have this one, minus 1.44, okay? Just like a plus because it's squaring, but it's okay. And then we have plus, uh-huh, right. Okay, because I put a plus, then you could just put the minus 1.44 here, and then you close, double, two brackets closing. Right, this is what the calculator gives. I need to sort of believe that this is correct. I hope we did not make any mistakes here, did not jump anything, but see, the idea is to illustrate the method that we are learning. Okay, is to illustrate the method. Minus 1.349487. Right. 714. Okay. Right. Just write this one. Right. So now this one here is the same as minus 1.349485.714. Okay. What does this estimate? Okay, we come here. We have seen that W2 approximates Y at T2. So W3 is going to approximate y at t3. So ideally, these things are like estimates. So, okay. Okay, we're just moving forward now. Right. So with the estimates, we are able to do the following. Okay. Now, for example, y at 1.3, right, 1.6. Right, because we said that the 1.6 corresponds to T3, so approximates WT3. Okay. Which is the same as W3. Okay. Okay, we got, which is like W3. Okay, need to use the right notation here. So I want you to say is it's like Y3 here. That's what I want to say. Not W. Right, like Y3 because T3 is that, which is W3. And ideally, when we write like this, we normally say because the Y is sort of the exact thing, but the W's are the estimate values. It's estimated at 1 minus 1.3. 349485714. Okay, this is exactly what you have. Okay, this is like W3 that we got. And then we need to get so many of them. Right, obviously we're just trying to learn the method here. Right, so we get all of them and then we get T10. You can tabulate all these values, and yeah, but in the exam normally they can't ask you so many because you actually would out of time so still doing this. But yeah, that's what you'd get. So this must proceed until we get to W10. W10, which is at T10. W10 is Y at T10, which is Y at, what is Y at T10? 30. Okay. Right. So obviously, what is this one here? We don't know yet because we would have to do W9 because for us to do W3, we need the W2 and so on. Okay, the idea is clear. But now I want us to continue and focus on um I think that what I'm gonna do, let me see. Oof, let me see. Okay. Right. Okay. Right. What I'm gonna do is I'm gonna illustrate another method. The method with the buzzword, but very important. Right, there's another method that we need to learn. And this method I need to learn is very, very examinable. I'm going to highlight it right now, and then we shall spend a bit more time on it. Now, there's something we call Taylor's method. Oh, sometimes the books just call it the Taylor method, not just Taylor's method, but some books have a tendency of just calling it the Taylor method of a given order. Okay, so we're going to do the Taylor method of order n. What is the Taylor method of order n? For example, Taylor method means what? Okay, it's similar to Euler. We have used Taylor. It comes in the exam. It came in November. But now let's see. So W0 is alpha. And then now it looks very similar to, in particular, we shall, I'm just going to justify the fact that Taylor and Euler are equivalent. Right, so Wi plus 1 is Wi plus H. Right. So we have Wi. Okay, this is true for each. For each I equals 0, 1, and minus 1. Okay. Where? Okay, in the example, they say use Taylor to estimate, like we used Euler. So now T sub I, Wi, so which is F, T I W I. Out of 2, okay, Ti plus dot plus H to the power n minus 1 divided by n factorial F to the power n minus 1 Ti Wi. Okay, yeah, this is Wi. Okay, I know it's Wi, but you need to make sure it's a little bit clear. Wi, not too small. Okay, there are a couple of things like we say Euler. Okay, Euler's method is Taylor. Okay, Euler's method is okay, is Taylor's method. We can appropriately call it Taylor's method, but sometimes it's called Taylor method. Right, but right, so Taylor's method of order 1. In other words, Euler's method is simply Taylor's method of order 1. So in other words, in Taylor, because in the case of Euler, we're just taking the first derivative here. But with Taylor, then we can take higher order derivatives. Say the higher order derivatives. So in other words, we can be able to estimate second order differential equations, third order differential equations, and so on and so forth. So Taylor is more general. So in the end, Euler's method is Taylor's method of order 1. Okay. Right. So with that said, it is therefore very important to note this. That in our next case, we shall be solving problems now using Taylor, but we shall be using the same approach as Euler. Here is an example of Taylor. It's the same thing. Taylor and Euler is exactly the same thing. Okay, here's the question. The question says apply Taylor. Apply Taylor's method of orders. Okay. Apply Taylor's method of orders 2 and B 4 with n equals 10 to the initial value problem. Right, this is an example. Right, it's an initial value problem. First derivative is y minus t squared plus 1, 0, like so. T lies between 0 and 2, inclusive. Y0 is 0.5. All right, so we shall do this question now, and then we shall just demonstrate how Euler is being used here. And you shall take note of this particular question. But now look, they're saying apply Taylor's method of orders 2 and 4. Okay, because now we need to do order 2 because this is a differential equation of order 1, first order, first derivative. So we're going to do the second order. Let's do the solution now. Okay, A part. Oh, okay. To solve this particular example, okay, we're finishing, please. We shall say here, in this particular question, we take f of t and y, which is y primed, which is y minus that, minus t squared plus 1. And then now we obtain f primed. We differentiate the f to get f primed, but it is f primed of t and y of t, which is d dt. Okay, so if we differentiate this one, we get t and y of t, like so. But now we just have to, okay, let me just write more, a little bit here. Right, so here we can just write y itself is a function of t. Okay, so that we just have f primed, and then we find the derivative of this. And then now we differentiate both left and right. So differentiate this one, t squared plus 1. Okay. Right. What is this? Okay, so if you differentiate now, this one is y primed minus 2t. Okay, y primed minus 2t. So what is y primed? Is y minus t squared plus 1. So it's t squared. Okay, because y primed is what? Y primed is, you substitute here, because we got y primed minus 2t, then derivative of 1 is 0. But y primed is given, so is y minus t squared plus 1, and then there's minus 2t. Okay. Okay, what is all this here? It means that f primed of t and y on t which is y minus t squared plus 1 okay, y minus t squared plus t minus, yeah, okay. Just consider that one. Right, so, okay, we need to remember what we said about the Taylor. Okay, let's just get back. Now but now we're dealing with second order. So we need to write this formula here and just replace n by 2 to make it second order. Okay, I know it looks threatening. It looks different. It looks new. These Taylors, that is the same. For Taylor that has multiple variables. You might have looked at Taylor, yeah, that has like single variables. So you have TIWI. You have T primed. And then you have n minus 1. N minus 1. Like so. Right, so obviously we're dealing with second order, which means we're going to have this one. Which is over 2. Okay. And then, okay. Because if this is 2, then this one, you put 2 here is going to be at only h over 2 factorial. So we're going to stop here. We're not going to like go all, because it's not going to make sense to go on, because if you reach here, 2 minus 1 is only h out of 2. Okay, so yeah. Okay. So you have this. Okay, now let's just continue. What is f of ti? It's what they give us at the beginning. So f is this one, which is y minus t squared. So, but in our notation, it becomes what? It becomes wi minus ti squared plus 1. It becomes wi squared minus ti squared plus 1. Okay, that is the given original. That's what they give there. They might give second order. Normally they give first order and then you can differentiate. Okay, because, yeah, okay. If they could give a higher order, you would have to integrate it. So that kind of thing. Okay, but yeah, normally you just differentiate to get higher order derivatives. So plus, now you substitute this one plus h over 2. Okay, now you find the derivative. It's this one here, which is wi minus ti squared minus 2 ti. Right. You have this. Okay. Okay, this is what we have. Now we multiply everything here, group-like terms, etc., etc. Meaning t squared of ti wi. 1 plus h over 2. Okay, which is wi minus ti squared plus 1. Like this. Okay. Because the wi, for instance, here is h over 2. And then you'd have, let me see what we got here. Okay, wait a minute. This square is not there. This square is not there. Okay, because if you look at the ti, just w, like that, minus t squared plus 1. It's wi minus t, minus ti plus 1. So there's no square. So that this wi and the wi, they just have their common factor here, giving us 1 plus h over 2. And then you have the t squared. Yeah, like that, like that. So now you just have the, you have this one here. Okay, and then now you also have the ti. Ti is just going to be minus h ti. Okay. No, you can show that this is exactly this. Right, because if you group the wi's, you get that the squares will be the same as the h over 2 here and 1, and then you pull that out. So it's minus t squared with the h over 2. And then you have also the h over 2 and the 1. So yeah, so those are 3, and then you have that. Okay, now you can easily verify that. Now with this we got, we continue right now. Okay, now I'm gonna say because, right, because there is n equals 10. Okay, the question they said n must be 10. Okay. Okay, we are moving really fast because I want us. All right, we have right. H in this question is 0. Okay. Right, we have H is 0.2. Okay, we'll discuss this just now. And we have the TI is I. For each I equals 0. Okay, for each I is 1, 2, 10. Okay, the question becomes, okay, we're gonna discuss this in detail. Okay, we're just moving there. All right. I'm going to discuss this slide in detail. Thus, the second order method, and I'm going to give some problems here. It becomes, okay, tomorrow we shall spend time on some past exams on these things and the exercises I'm going to give now as well. Okay, so, but you must do calculator practice on these. Okay, so yeah, your calculator must be very handy. Okay, because we know that in this question, y primed, y minus t squared plus 1. which is 0.5. Okay, look at these now. This is the question. If we have that n equals 10, n equals 10. So how many i's will be there? So it means, therefore, you would need, therefore, that you have 0.2 plus 0.4 plus 0.6. Okay, you start at 0. T0 is 0. Then there's T1, 0.2. Okay, you add 0.2 just to understand why the n is 10 and so on. 2 is 0.4. 3 is 0.6. And then 0. Something something. Okay, I can write it horizontally. 0, then 0.2, then 0.4, then 0.6, 0.8. We're moving something 0.2 so that you can understand why these here that we use in the Taylor calculations. So it's 1.0. Okay, but we must go because between these up to 2, from 0 up to 2. So which means 1.2, 1.4, 1.6, 1.8, 1.0. Now, look at this. You're going to say, just we're practicing with this. T0, T1, T2, T3, T4, T5, T6, T7, T8, T9, T10. Okay, our approach this time around is just going to be practicing the formulas, the statements of the things, of these methods, and then we look at how we can apply them in the exam. Okay, now if you look at these, then we have T10. So that is why then we say, because n equals 10, we have h equals 0.2. And now we understand, therefore, that if h is 0.2, then we must move in steps of 0.2, so that if you actually, therefore, take 10 of these, then you get to 1.0. Okay, for each of the i's from 1 to 10. Okay, because the i's themselves are for 1 to 10. Okay, now let's see what else. We need to obviously do the calculations here. Like we did with the Euler, but we are using second order. But now let's do the W0. W0 is always Y0. We saw with the Euler. So that one is exactly, W0 is Y0, which is 0.5. What is W1? Okay, we saw that W1 is Y at T1. Can you write that one? Approximately. What is Y at T1? Okay, you can use the equal sign here. Okay, so this one is Y at 0.2. Okay. What is Y at 0.2? Okay. That is what we're estimating. That is what we're estimating. Right, because we don't know the exact equation yet, the solution to this. But now we know the formula. Right. You know the formula. What is the formula? Okay, we got the T2. So if you got the T2, then you come to the Euler, to the Taylor. We got the T2, then you must put it here. Because the formula will therefore say to get the rest of these is Wi plus 1, Wi plus H. So we want to get the rest, so which means Wi plus 1 is Wi plus h t n of ti wi. This is the nth order derivative. Okay, so just take note of exactly that there. Right. And then obviously this is for each. Okay, I'm concluding, please. One, and then I'm going to give a couple of exercises. All right, so second order is what we want. So which means that n is 2 here. We've already got n equals 2, but we shall just be plugging it in here. So obviously we understand that when n is 2, what is this Tn? Okay, T2, it's exactly this. Okay, T2 is exactly this. So which means that it's exactly 1 plus h over 2. And then is the Wi minus Ti squared plus 1 Ti. Okay. So this becomes sort of the formula here. We've put the T n here, but yeah, we understand that n equals 2 because we're dealing with second order. N equals 2 here. Second order. Second order differential equation. Okay, we have rounding up for finishing, please. So now, with that said, let's just do some calculations of this and see what we can get out of this here. Okay. Okay, this one is going to be quite short. All right, let's see what we achieve. Right, we're going to get Wi plus 0.2, which is 1 plus 0.2. And then is Wi. Okay, 0. Okay, obviously the Ti, we've already seen that we say it is 0.2. 0.2i, and then we're going to square it. So it's going to be 0.2 is going to be 0.04 and then I squared plus 1 minus 0.04. Okay, because the age is 0.2 and then the Ti is 0.2, then it's 0.04 I. Right, so what is Wi equal to? Okay, so that one we obviously are writing the formula. So we need to just note it. Okay, we note that, but yeah, right. So if we add like group like terms and so on here, it's going to be 1.22 Wi. Okay, so this is squared. Plus 0.22. All right, so this is the equation then. Okay, this is the formula we've got that we're going to use. For example, we want to get W1 when I is 0. So it's going to be 1.22 W0. Okay, I0. Zero point zero zero eight zero 0.22. And if you do all this, is 0.83. So this ideal is W1, and it is 1.02. Okay, let's look at this one here. Okay, so we have this. Okay, so the Y02 is W1, which is this. Okay, W1 because it says 02, because W0 we know is the initial value, which is 0.5. Okay. W0 we know already, once again, is 0.5. Just put here it is 0.5. This one. So add everything, you get 0.83. All right, so which means that we found an estimate of 0.2, which is 0.83. Okay, let's just do one more. Okay, and okay, so we're gonna do, this is W1. Let's do W2. So Wi plus 1, Wi plus 1 is the same as Wi plus H. Okay, this is the formula we got. HOT is these multivariable functions for Taylor do this. Squared plus 1 HTI. Right, so now T plus 1, 1.22 Wi, 0.0088I squared minus 0.008I plus 0.22. Okay, we want W2. So 1.22, because I is 1, 0.0088. Okay, because I is 2, then you put 2 here. No, I is 1 to get 2 here. So because I is 1, so yeah, I can put 1 squared. 0.008, you put a 1 here plus 0.22. So, all right, W2, 1.22. W1, what is it? 0.83 minus 0.0088. Okay, this is just 1 minus 0.008. Okay, okay, just watch this out. Okay, right, so we're dealing with W2, so this is W1. This is 0.83, okay, because this, therefore, is 0. Just need to check this. 0.00800. Okay, so this one is going to be 0. The I here is going to be the next I, so it's going to be 0.2. Okay, just watch that out because of the usage here. We need to be very careful. So this one is going to be 0.2. Right, so it's going to be 0.2. Please just note that. So this one, okay, because remember it's H. Yeah, it's H that is in steps of 0.2. So this one is going to be 0.2, but you square it. So it's 0.2 and you square it. Um, 0.2 and you square it. Okay, just note this. Okay, if you use a calculator then to do everything here, let me just clean this up. We're going to do more problems on these just to make sure that one is understands the notations here. So it's 0.0088, 0.2 squared, 0.008, 0.2 squared, 0.22 or 0.22. Okay, so which means W2 is 1.2158. Okay, and then now this W2 once again estimates the second one at T2, which is 0.4. Estimates W2, which is 1.2158. So yeah, okay. But yeah, we need to do, because now T in this question lies between the 0 and 1. Like 0 and 2, excuse me, 0 and 2. Okay, so we must go on until we have 2.0. Y of 2.0. That is what we must estimate. Yeah, but it's going to take us a while. But that is the method. I'm going to obviously speak a little bit more about this method just to make sure we understand more problems with this. But let's just give some exercises for the evening. Okay, yeah, I'm going to spend time on some exam questions, but I want us to always cover background information and textbook exercises as well. That is what is will sort of be different in our approach. Right, so use Taylor's method of order 2. To approximate the solutions for each of the following initial value problems. Okay, now if you look at the part A, use Taylor's method of order 2. Okay, it's exactly what we are doing now. So y primed, this one is t e to the 3t minus twice y. T lies between 0 and 1. Y at 0 is 0 with h is 0.5. So we have y primed, t minus y, to t3, y at t is 1 with h 0.5. C, y primed, 1 plus out of t, t, 2, t, would I, y at 1 equals 2 with h equals 0.25. We're going to do a lot of practice tomorrow, please. We're going to play around with this just to create the kind of dexterity, but also to build more confidence and familiarity with the estimations. One thing with these, they take a little bit of time to do, but if one has the formulas at the disposal and calculator usage is optimized in terms of practice, etc., and there's much familiarity, then we are good. Okay. With h equals 0.25. Okay. Right, use Taylor's method of order 2 to approximate the solutions for each of the following initial value problems. So yeah, it's what we're doing now of order 2, but you can do higher order as well. We've seen how we use the Taylor's method to solve these particular problems. Okay. We shall spend some time on some exam questions as well, and so that we can sort of understand what is happening there. Okay, right. These were just the textbook exercises, please, on the two methods, Euler and Taylor. I must thank you for joining us today. These exercises, okay, just call them exercises. Right, these exercises, I'm going to spend some time on them as well. We're going to spend some time on them tomorrow. So it will help to, you can do one or two. You don't need to do all of them. But yeah, we shall spend some time on them tomorrow to make sure that we are familiar with these, etc., and we can analyze them and so on and so forth. Okay, but I must thank you for joining us today. I must be able to see you tomorrow. We must meet tomorrow at 4:30 if you're available. Okay, I want us to just build some momentum. And there are lots of topics we still need to cover. There's still practice we need to do together. Your calculator will be of essence to be brought along, because just to make sure that you can just be familiar with the things. And I can give some exercises. Yeah, but exercises during the discussions sometimes do not work well because they take time. I wouldn't want to wait for you to get the answer to a question, that kind of thing. But at least if you try at home today, any of these ones on Taylor or the other ones on Euler, and then we can see what to do. Okay, but yeah, I must be able to see you tomorrow. We must meet tomorrow at 4:30 if you're available. Thanks a lot for joining us. See you tomorrow at 4:30 in the afternoon. But I'm also going to make this video available in the next couple of minutes, okay, so that you can just be able to see the things and One thing that is going to make these things familiar is to write them down in a book. You need to write them down in a book. So, um, so that you can refer to them, you know, and try to make sense of them. Okay. Yeah, I must thank you for joining us. I'll see you tomorrow at half 4. All right. Thanks a lot. Goodbye.